So question number 21. A Zener diode in the circuit shown in the figure has a knee current of 5 milliampere and the maximum allowed power dissipation of 300 milliwatt. What are the maximum and the minimum load currents that can be drawn safely from the circuit, keeping the output voltage V out constant at 6 volt? Okay. So this is the circuit given. You have a load, a Zener diode, 50 ohm resistor, and a 9 volt battery. Okay, and IZK, that's the knee current for the Zener diode is given. This current is basically the minimum current for the Zener diode that has to flow through the Zener diode in order to work this properly, this particular diode. Okay, so this is the minimum current, okay, in order to perform the Zener action, and the maximum power dissipation is given. Okay, that is 300 milliwatt, that is 0.3 watt. So from that point you have to understand that you can determine the maximum current that can flow through the Zener diode. You can determine from this point, okay, because we know power is basically voltage into current. What is the voltage across this Zener diode is basically your 6 volt, and what is the maximum current? Okay, maximum current is IZM. Okay, that is basically your 0.3. okay, so you can find IZM is basically 3 by 10 into 6, that is 1 by 20 ampere. This is okay, so this is basically your, if you multiply 1000, that is your 150 milliampere. Okay, this is the maximum current that can flow through the Zener diode. Okay, the next thing that you have to understand is that the voltage across this Zener diode is constant when the Zener action is performed. Okay, so the current that coming from this source is constant. Okay, as load varies, so the current through the Zener diode will change and current through the load will change, but sum of these two current is constant because this voltage is across this voltage is constant. So this particular voltage difference across this 50 ohms resistor is constant. Okay, so what is the current through this 50 ohm resistor? Let's say I50. okay, this is basically your I50. okay, so I50 is basically how much? 9 minus 6 divided by 50. So this is basically 3 by 50 into 1000 milliampere. Okay, 60 milliampere. Okay, so this is basically a constant current. Okay, now the next thing that you have to understand is that when this particular Zener diode consuming the maximum current, that is 50 milliampere, that time the load is consuming the minimum current. Then what is the minimum current of load? That is IL minimum, that is basically 60 minus 50, that is because the 60 is the total current. Okay, that is basically your 10 milliampere. Now when this Zener diode consuming the minimum amount of current, okay, that time the load is consuming the maximum amount of current. Okay, then what is the maximum current? IL max, that is basically your the total current 60 minus this 5 milliampere. Okay, so this is basically your 55 milliampere. Okay, so let's see the answers. So minimum and maximum current respectively is option C, 10 milliampere and 55 milliampere. Okay, so option C is correct.